So this is the last slide on mode curve analysis. So let us draw some conclusion based on what we have learned so far. So let me explain this table. So if you look at this table, what we have here, let me explain this table. So the first column, it says full cycles. So we have discussed the equation. So this is the equation for mode curve. We know that and so on. So this describes the full cycles n, small letter n, and this is the fractional cycles, capital letter N, and then this is the reflector voltage. We know it is negative, so it has negative values. This is the power output of the klystron oscillator. This is the frequency deviation of the oscillator. So this is our oscillator. So we have power output, we have frequency output. And we know in our example the frequency was 10 gigahertz, and this is the deviation from 10 gigahertz. So plus or minus FD. Now if you look at the first row where n is equal to 0, we get capital N is equal to 3/4, and we see that this is this mode is suitable for applications that require high output power, because the power output is very high, it is 1 watt, and it has low frequency deviation. Okay, that means the frequency is very closer to 10 gigahertz. But the biggest disadvantage is that the reflector voltage is very high. Now if you look at n is equal to 1, that is the second mode. Here this is suitable for applications that require medium range output power. So the output power is not as high as n is equal to 0 mode. It is slightly lower at 700 milliwatt, and it has a better tuning. So the deviation is wider, but if we want to tune our oscillator, then maybe this is better because we can also tune the oscillator. Okay? And the lower voltage of the reflector electrode is good, because lower voltage is good. Now if you look at mode n is equal to 2, this is suitable for applications that require low output power. Okay? And also the frequency tuning is better because we have wider deviation depending on application. If the application requires wider deviation, then this is good. If the application requires low deviation, then this is good. But if you want to tune the 10 gigahertz to a different value, then this is better. We can do 10 gigahertz here plus or minus 12 megahertz. Okay. The biggest disadvantage is that the reflector voltage is much lower compared to the other modes. So this ends the mode curve analysis discussion.